Okay, I believe some of you know what is Shimadzu Malaysia, right? Yeah. So just a briefing. Shimadzu actually is a corporation from Japan, Kyoto, and the business outline including analytical instrument, testing and measuring, medical system, aircraft equipment, and also industrial machinery equipments. And as subsidiary of Shimadzu, we have a Shimadzu Asia Pacific located at Singapore. And for this region, actually they take care of about 15 countries in Asia. One of the country is Shimadzu, Malaysia. Our location is Kota Damansara and start operation since January 2015. And our business is most on sales and service of analytical, scientific, and medical systems in Malaysia only. We have one branch in Penang, and this is the location in around Bayang Lepas, Pulau Pinang. And we also have one manufacturer, Asia, in Sendayan. And this one start operations 2016. And this factory actually, all the part is from Japan, and we just assembly in Malaysia to support an Asian country. This is our support team, sales team. Technical service, this is from our service engineer. And last one is our CSC, Customer Support Center. Yeah, this is mine, then the rest is my colleague. And we also have our CSC lab. Yeah, you can see this is our lab. So we have a lot of instruments inside. And we also provide in-house training, on-site training, troubleshooting, sample analysis, and so on. What we have, this is our product range. We have ultra-fast mass spectral, GCMS, different model GCMS, LCMS, and so on. Which label new actually is new launching. TQ is triple quad, QP is a single quad. LCMS. Excuse me. For technical support, this is technical support. They are specialized in technical support and service of hardware. So this is under service department. They do installation, commissioning, troubleshooting, and also carry out IQ/OQ. IQ/OQ actually is for pharma request lah. And they will do a configuration and development of customized GC. And preventive maintenance package is also under technical support center. They have preventive maintenance plan, comprehensive maintenance plan, and customized preventive maintenance plan. Go to chromatography. We have a GC and LC. Yes, this is new launch, Maxera XR, S2, and also X3. And prominent eye actually is a combination LC. This one batch only, built-in one. And this one is a upon customized. You can add on some different farm and different detector and so on. Next is our spectral. Our spectroscopy, including UV-Vis, RF, and FTIR. That's a different model. UV, this is IR, and sorry, this three is IR, and this is RF. So as ICP, ICP-MS, AES, and also TOC. Yeah, this is our focus point, TOC benchtop. Single size analyzer, and some data management and software. Just an introduction. Okay, next, I will introduce what is Shimadzu and some application. And this is my name. You can call it me, you. And this is my contact and email. So after that, if you have any question on Shimadzu instrument, no matter what type of instrument, spectral, chromatograph, you can contact me. I will pass to my colleague if I cannot handle. And this is my table content. I'll introduce what is Shimadzu TOC and also the application of TOC in different fields. Yeah, this is TOC. So actually, TOC is an instrument that can measure total organic carbon. So if you refer to the model, actually you can see something like, maybe I can draw something. You will see this, 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 this. Okay, these few things. C, what is C? C actually is stand for combustion type. Means we need heat to detect your TOC. S is stand for like this model. You can see the screen and buttons, right? Means I can measure TOC without any PC. P means you won't see the screen, no more screen here. Means I have to connect to PC. N is stand for normal sensitivity. And normal sensitivity is referred to about ppm level. H means high sensitivity. Means we can detect lower than ppm level, such as ppb level and so on. Actually, it depends on your application. If your sample is ppm, actually you no need to go to pph. TOC actually is a method to detect pollution in the water. So we can have effluent water, surface water, drinking water, and pure water. In other words, if you detect higher organic substance, means your water is more dirty, right? So, and in some country, TOC actually they can accept it as a new index of organic pollution. That country including China, Japan, some Europe country, but not including Malaysia. Why we want to use TOC? Yeah, this is the advantage. TOC can determine the amount of carbon in both organic and inorganic substance directly. Second one, sample matrix does not interfere with the TOC analysis. Means, although I have some metrics, for example, other material like organic substance and some inorganic substance, but don't worry, these metrics will not interfere our result. And then we have short analysis time. It will take about 5 to 7 minutes only. This is considered very fast if we compare to BOD, which take 5 days, and COD, which take more than 2 hours. And what is BOD and COD? Actually, these two things are conventional index used to indicate the organic pollutions in water. Malaysia still using BOD and COD. Okay, what is this? BOD, the full name is biological oxygen demand. Measure the oxygen needed to biological degrade organic materials. Advantage. They have more than 100 years history and very popular in the world. And this biological treatment actually is used for wastewater treatment. Disadvantage, time consuming. We take 5 days in Malaysia, and the activity of bacteria actually is not so stable and not easy to treat. Next is COD method. COD is chemical oxygen demand. It's the oxygen consumed by reducing substance using a strong chemical oxidant. Advantage. COD actually is same like BOD. It's very popular in the world and have more than 100 years history. Disadvantage. Time consuming. We need few hours to digest one sample. And we also have a strong interference by reducing material. And the worst thing is to measure water pollution. We generate more pollution with this method. Just take note, this chemical oxidant is a pollution as well. TOC is a new method to detect the carbon directly. Advantage. First, free of interference. Second, fast measurement. Within 10 minutes, we can get one sample, and we can detect all type of carbon component. And this TOC is better suited for automatic analysis. Means we no need a very experienced operator. Even a new operator, they also can perform the result very well. Disadvantage. TOC is not like BOD and COD. Not so many countries can adopt TOC as the official method for environmental control. In history, we have more than 50 years history, and we have a normal and high sensitivity combustion. Yeah, as I explained just now, normal sensitivity is ppm level, and high sense can cover until ppb level. Like pharma, they need lower concentration, so we need to detect in lower ppb level. And we use 680 degrees Celsius combustion method. And with this temperature, it's possible to measure seawater as well. Why we need to use 680? Previously, TOC involved complete oxidation of carbogenous material by a catalyst. Last time, we used up to 1000 degrees Celsius. Okay, but after that, we found this high temperature actually is not suitable for seawater. This is because all salts are melted. And after melted, they will attach to the catalyst, to the combustion tube, and also the carbon as well. So actually not so suitable for salt. So after that, we found out 680 degrees Celsius is the best to measure seawater and also fresh water. And using this temperature, detector damage and interference are kept to minimize, and we also can increase the lifetime of the furnace as well. Okay, this is some terms. TC, IC, TOC. Okay, what is it? TC is referred to total carbon. TOC is total organic carbon. IC is inorganic carbon. TOC is purgeable organic carbon, and NPOC is non-purgeable organic carbon. Yeah, you can see TC divide to two, IC and TOC. And for TOC, we also divide to two, NPOC and POC. Okay, what is it? NPOC. NPOC is the species left after the sample is acidified and purged to remove IC. Means this is your sample. We adjust the pH and then we sparge it. Anything left is known as POC and IC. So the species left here we known as NPOC. This is another method to measure. Okay, let's see the determinations. We have two different types method of determinations. First is called differential method. We obtain TOC by subtract TC minus IC. When your TOC is much higher than IC, such as in wastewater. Because in wastewater, we have very high organic carbon. So in this case, differential method is more suitable. Another scenario, let's say we run a pure water. Pure water, normally IC is higher. So if I still using TC minus IC, very high probability I will get minus TOC. Actually, this is wrong. So in this case, I have to use NPOC, means I purge, acidify to remove POC and IC. And I can report my NPOC value as my TOC value. This is accepted in standard method. Okay. This is, we call it as a main unit. Main unit is referred to water base only. Let's say I have another accessory. If you have non-water sample, for example, liquid oil sample or solid sample, you have to use solid sample module, as I said. And if you have a lot of sample, I can use AUTOSAMPLER. Means AUTOSAMPLER can help me to measure the sample automatically. Okay, this is AUTOSAMPLER. Can reduce manpower. recommend for large number for convenient use. We have 93 vials. You can put, so means one shot I can run 93 samples. And normally I'll run overnight. And for solid sample or non-equal sample, actually we can use this as how to run. For TC and IC determinations, liquid samples are injected directly for combustion tube and acid chamber respectively, right? But for solid sample, we cannot direct inject. We have to place in a ceramic board and then we place in a heated chamber. For IC, we need to place a ceramic board and also put some acid to digest. So after one-time installation, we can switch between aqueous and solid sample without further conversion. Just make sure one time I can either measure liquid or measure solid. I cannot run simultaneous. Determination. The sample weight is actually you weigh into a ceramic board, and then I can push into the TC and IC chamber separately. Each one will take about 5 minutes. Initial. We use as index to supplement BOD and COD in field of TOC analysis in environmental studies. Currently, with increasing the sensitivity, the application has been extended into pharma, semiconductor, and so on. So you can see here, this is for processed water. Last time, processed water is very high, it's percentage. Then go by wastewater. Wastewater is in high ppm level. Then after that, we can detect in low ppm level, such as drinking water. And in pharma, actually is in ppb level. And if nowadays in some application in the semiconductor, they request PPT level, part per trillion. That one is very, very, very low concentration. But depends. Let's say your samples is wastewater. Actually, you no need to go to PPT level. You only need ppm level. So we can see the application. We can apply to pharmaceutical water control. For example, USP, EP, JP, IP, and CHP. P is pharmacopoeia. So US is US, Euro, Japan, India, and China. We also can control the drinking water. So for example, you can test your drinking water. How high is your TOC? If not mistaken, the TOC value in drinking water cannot more than few ppm, about 2 to 3 ppm on the maximum. Wastewater control. In some country, they can replace COD and BOD. And also not forget for environmental analysis like teaching and researchers. Okay, let's say if we want to replace BOD or COD with TOC, actually we can. Yeah. So far, because TOC is faster technique if compared to BOD and COD. Just take note, no universal correlation between COD, BOD, and TOC. So in this case, we need to do some testing. We try different sample. Same sample, I run TOC and also run BOD or COD. After that, I can try to get your relationship. Okay, and from here, I can plot to get your R square. This is coefficient correlation. Make sure the R square is more than 0.9. And you can convert your sample. By using this equation, it's possible to convert the TOC value to COD and BOD. And this is more simple method. Okay, means next time you only measure TOC and you can direct convert to BOD and COD. Just take note, the sample must be in same batch. Different batch or different metrics will give you different equation. So we need to do study. Yeah. This is the possibility that a correlation equation might change in the following cases by changing the product, changing the amount of the product, changing the status of wastewater treatment system, and so on. Okay, before I end, I will share few application notes. Yeah? We can go one by one.
Okay. Now we can
Yeah,
see the
sorry.
application note.
Again, sorry.
PDF version, right? It's in the PDF.
Yeah, this is PDF. So if you want, I can share with you later. So this is application news 061. We try to compare the analysis of blue-green algae suspension. So we take the sample from the lake, and yeah, it's like this. A very thick and very high concentration. We separate to two. One, I try to use mains unit for liquid sample, for water-based sample. So for liquid water-based sample, I need to do dilution because this is too high concentration. Yeah. So take note, the highest concentration for main unit should not more than 1000 ppm without dilution. Okay. Your sample, you know, is a percentage. Please dilute the sample first. And for this unit SSM, actually we need higher concentration. So that's why for SSM, I do not do any dilution. This one I dilute 100 times. This one I don't have any dilution. Then I compare the result. Sample for diluted sample, I get 109.7. And this is after dilution, right? So I need to multiply back the 100 times. So I will get 10970. So if I convert to this milligram ppm, I will get close to 1.1%. Okay. How about the SSM? SSM, I get 1.08%. Yeah, actually it's quite close. In other words, if I want to measure as algae, actually, this one can be measured. This one also can be measured. Okay. Second one, we want to measure the cement. So for cement, we cannot run with main unit, right? Because cement is in liquid form. So we have to use, sorry, cement is in solid form. We need to use SSM. So we get two types of sample. Sample A and sample B. So for sample A, I get quite similar TC value. The difference is IC. IC, the difference is about 0.1. So for TOC, I'll get the result also about 0.1 difference. A is 0.2, and B sample, I'll get about 0.1. Okay, third application. Can see, right? Yeah, there's a CO2 determinations in beer. So as we know, CO2 actually is an important ingredient in soft drinks, including beer. So last time we have a method. The method is not easy, take very long time. So after that, we try to replace with TOC method. Okay, we can see the result. Yeah. The blue color one, the blue color actually is our TOC method. And the green color is Corning method. Corning method is a conventional method. Yeah, the result is quite similar. So means TOC actually we can direct measure CO2. How to do? Yeah, actually not easy, not so complicated. We place a sample in 40 ml auto sampler vial, and I add 5 ml of 32% of sodium hydroxide to preserve the CO2. After that, I direct measure IC to detect TOC, to detect CO2. Next, we try to do comparison between the COD, BOD, and also TOC. We can see the result. Okay, first, I try to use glucose. COD, I'll get 1067. TOC, I get 400. So the correlation about 2.66. Second, I try acetone. COD, I get 2002. TOC, I get 621. The correlation about 3.5. Next, ethanol. COD is 2087. TOC, I get 522. The correlation is about 4. So actually, the correlation of COD or BOD or COD actually is depends on your sample. The range could be from 2 to 4. Okay, it depends on your sample. Next application. We can measure oil residue on metal pipe using TOC SSM. Okay, how we do? So first we cut the stainless steel pipe into a segment approximate 3 cm long to enable it to place in the ceramic. Okay. Then I separate to two. One is clean sample. B is clean sample. And the other sample is without cleaning. So clean sample, I get about 2 ppm. Not clean sample, I get about 20 ppm. So I need to minus. So I'll get about 19 ppm for your unclean sample. This is some oil residue. And the oil is very less, a little bit only. Okay, last one. Last one is this. We can determine according to USB 661.1 testing of plastic packaging system. Okay, how to do it? First, we need to take 25 grams of plastic material and you cut into a small pieces. And then we top up 500 ml of purified water and boil it for 5 hours. Allowed for cooling. After that, we try to measure the TOC. And the TOC value cannot be more than 5 milligram per liter. Yeah. And actually, we try to run, and the result actually is quite low. It's less than 5 ppm. So we means the plastic material we detect actually is still safe to use. Okay, so I just show you 6 application notes.
So thank you, Mr. Yu Wei Ming. He's the senior application chemist in Shimadzu, Malaysia. So now we will proceed with Ms. Yusiawati, our CAL lead technologist that is handling the TOC unit in UTP. Okay, over to you, Yus. Yus dah ready?
Okay, ready.
Okay.
Okay, Assalamualaikum and good afternoon, everybody. Okay, I want to share about, wait. Okay, can you see?
All right, okay.
Okay. This one, TOC webinar for today. Okay, TOC analysis carry out in a wide variety of environmental metric from groundwater to seawater, from drinking water to wastewater, from soil to sewage sludge. Okay. Okay, this one, typical concentration for surface water. That's the range. This one for the reference. Okay. This one for liquid sample. As a river water, lake water, seawater, groundwater. That's the example for liquid sample. Okay, for solid sample, we also have classification of soil, sludge and sediment. For solid material, you need to grind to produce it into a small particle before testing. This one, the example for solid sample, shale, sludge, soil and rocks. This one is example for good sample. Good sample is clear and they have a fine particle but not so bigger. This one, solid sample that you have to grind first. Okay, bad sample, these are too many particles and not homogenized. You see, they are suspended, so many suspended. We don't want this one. You have to take the supernatant, or maybe you can take, you can remove the particle, or you can use the sonicator to homogenize. This one last material. Before, sometimes I get the sample is rock. You know, a bigger rock. They send the sample like that. You have to grind first before submit, yeah? Okay, this one, that's all. And share the others. This one for operational. Okay. Okay, this one. This is TOC that we have in UTP because due to type. This one is for Shimadzu. We use carrier gas, purified air for liquid, and then oxygen for solid measurement. This one is washing container. You have to ensure the container have water inside it because every time after it finish the sequence, it have to rinse the tubing. We don't want to contaminate the sample. This AUTOSAMPLER we have. Okay, and then we switch on equipment. This one for liquid. And then that's the software we use, TOCL sample table. Okay, this one is selection. The system, we have two systems. One for TOC ASI for liquid sample, SSM for solid sample. All the event, the status is in this chat box. Okay, this one is sample information. We have to select the method, and then we have to insert the wire, insert the sample name. All we do here in sample information. Okay, there's a 8-port valve operation during the sampling. We have the video here. This one during the taken the sample. You see the valve is moving. The valve is taken the sample and then it goes to the combustion and then it goes to the inside the machine.
You dah gerak slide ke?
Dah. Tak ni lah video.
Tadi video dah jalan.
Okay, slide belum? Tak habis lagi.
Tak takut lagi internet aku ke?
Okay. Video disangkut sikit. Okay. This one for sampling. Okay, this one, you have to make sure they have spudging here for the gases. Okay, this one during measurement lah. First, it will detect TC first. One sample around 50 minutes. It depends on the method we select. Okay. After that, it will detect IC value. And then, this one also depend method selection. And then this one is sample result. Like Mr. Yu already told, to get TOC, TC minus IC. That's why it measure TC first and then it measure IC and then it's calculate the TOC value. Okay, this one for solid. Okay, after that we just return to the sample. And then this one is sample pit for measuring lah. Also same like solid, TC first and then IC. And then it give value for TOC result. Okay, that's all.
So hopefully everyone, thank you very much. Okay, so I'm still, if you still have question, you still can raise your hand. Okay, all right. So now, okay, we've already finished with the operating. So now it seems that we already arrived to the end of our session. It seems. Okay. So hopefully all the participants, you can scan the QR code and hold on. I just copy the link and put in the chat. This one is for our continuous improvement. So please free to give your feedback because we can further improvement on our for the webinar series. And just to inform you, our next CAL webinar series will be on XRD, most probably in June. So hopefully everyone can join as well. Thank you, Mr. Yu Wei Ming. Thank you very much for having your time, spending time with us, sharing your knowledge on the TOC. We really appreciate it. And then hopefully your recovery okay already? Last time?
Yes.
Okay.
I resume for work by today.
Okay. All right. And then as well as Yusiawati, thank you very much also for demonstrating and all the video prepared for this webinar. And hopefully all our participants, you also gain knowledge on what is the basic of the total organic carbon. And I think that's all for today. So we will finish early. But it's okay for those, as you know, we already record the session. So if you want to just to revisit back the learning materials, so feel free to inform. I can also share the link as well. And I think that's all. Thank you once again to our presenter as well as all the participants for today's session. Thank you very much. And hopefully stay safe everybody during this. It's still endemic. Yeah, it's going to be endemic. But please be careful. All right. Okay, I think that's all. Thank you very much. Assalamualaikum and a very good afternoon, everybody.